Here we have several mud puppy skulls, and what I'm going to try to do is show you some differences here. One of the things we talked about in class at the end of the week last week was the visceral skeleton, the Splanchnocranium, and how that reflected with the rest of the skull. So although it's damaged, this skull here is most of the true skull. Now, what makes this different from the shark is it's bone, right? But it's actually more than just bone. The shark skull was just a chondrocranium. Those bone cartilage will be replaced by bone in the mud puppy and in your own skull. But there's also another component on the top. So some of the bones here have nothing to do with the cartilages in the chondrocranium. They developed from skin bones, dermal armor, that migrated down and covered the top of the skull to help protect the brain. And so we call that dermatocranium. Derma referring to the skin, and we'll be talking about that in a lot of detail on Friday, when there'll probably be better attendance than there will be tomorrow. But one thing that also makes this a little harder to see is that the jaws, the upper jaw, is actually attached. Oops, where are we at? Okay, so.
No, sorry. That one?
So the upper jaw and lower jaw is here, obviously, but the upper jaw is actually attached to the skull, unlike what we saw with the shark, right? So here's our first visceral arch, the mandibular arch. And we have a lot of different bones here. Here's our premaxilla. Here's our palatopterygoid. Palatopterygoid, remember the upper jaw of the shark was the palatopterygoquadrate? Palatopterygoid articulates with this bone here, which is the quadrate. And that's why I wanted you to learn that long name, because it makes it easier to relate the two animals. And then here's the lower jaw. And of course, well, Nick could go over this. Nick's terrified now. Well, Nick's in mammalogy with me, and one of the things we see happening is the number of bones in the lower jaw between amphibians, reptiles, and then mammals diminish. So we have a lot of bones here, and that's different, right? All we had in the shark was cartilage called Meckel's cartilage. So during development, all those cartilages that we saw for the shark's jaws get covered by bone, and that bone replaces it. And so most of this here is the bone you think of as your mandible, also called dentary. If we look, it's kind of hard to see, although that's why I grabbed the big one. Can you see that? Yeah. So on the inside there's something that looks like a rooster's crest with some teeth on it. Now, see how it's separate from the rest of the dentary? That's a little bone called the splenium. And then we get into the corner, and you can see this line right here. That's where the dentary meets another bone called the angular. It's at the angle of the jaw. And then when we look at the top here, whoops, it looks like we've got glue here, doesn't it? But it's actually cartilage. And you all know that cartilage's name. Right, Meckel's cartilage. So you see the remnants of that. In fact, we have some sea turtle skulls around here somewhere. They remodeled the lab, so I'm not sure exactly where. But their Meckel's cartilage is replaced so late in development that their lower jaw is hollow. And you can see that. You can see where the Meckel's cartilage was. So these are all the components of the lower jaw. Second visceral arch is going to support the jaw. It's the hyoid, right? So the one piece in the middle that's beneath the rest of the hyoid, hypohyal. And the two going up to the sides like bull's horns, ceratohyal. One thing we see different, because the upper jaw is fused to the skull, we don't need to have as strong a bracing like we did with the shark. And so we don't have a hyalomandibula like we saw with the shark. And then we get down to, I'm going to use this guy for it. Actually, I forgot to show you that here with this little jaw by itself, you can see the Meckel's cartilage really nicely there. All right, so here we can see there's our ceratohyal, hypohyal, and then we've got this piece here called the basibranch, which, well, actually all these are pretty much broken except for this one here. This is one of the few bones of the gill arches. Most of the gill arch structure is cartilage. So here's the basibranchial, there's 1 and 2, and then we have this gill arch curving up, right? That's going to be a ceratobranchial, again like a horn. And now this is our third visceral arch, but our first gill arch, our first branchial arch. On top of the ceratobranchial, we have epibranchial. Does that remind you of the shark at all? And what do you think we call the epibranchial on top of the first ceratobranchial if we're gonna give it a number? First. That's even easy to spell. So that makes sense, right? And of course, what gill arch is this? Number 1. And what visceral arch is it? Number 3. Does that make sense? All right, so we're gonna see the same thing. Here we have epibranchial 2 and 3. The only thing that makes it hard here is epibranchial 2 and 3 sit on one ceratobranchial right there. It's that intersection. So there's our second ceratobranchial that supports our second and third epibranchials. So if I was to tag this on the day of the practical, and I said, name this epibranchial, what number is it? Number 3. What branchial arch is it part of? 3. And what visceral arch is it part of? 3 plus 1 for the hyoid, 1 for the mandible, gives us 5, yep. Does that make sense? Okay, that should help a little bit. Sorry, got a little saliva down my throat. And then later on, I'll probably walk you through some of these other features as well, because they're hard to see. Okay?